The next topic is Matter and Materials, Chapter 7, Learning Outcomes. So once we finish this chapter, you should be able to understand these things. Define density, define pressure and calculate the pressure in a fluid. Understand how tensile and compressive forces cause deformation. Describe behavior of springs and understand Hooke's law. In the O-level class also you would have learnt about the Hooke's law. So we will see that again, and we will see it in a bit more detail. So we have tensile and compressive forces. Now if you have something like a rubber, a spring for example, if you pull the spring from both sides, you are applying a tensile force. If you press the spring, that means you are applying a compressive force. Both of these forces cause a change in the shape, which we call deformation. So both of these forces are deforming forces because they change the shape of the object. So define pressure, we have learned about pressure in the O-level class. Pressure equals force over area, and also we learned the equation for pressure in a fluid. Pressure equals rho gh. Then we learned about density. We learned the equation for density. Density equals mass over volume. Distinguish between elastic and plastic deformation. Again, in the O-level class, we learned about elastic and plastic deformation. Now, if something is deformed elastically, once the deforming force is removed, it returns to its original shape. If something undergoes plastic deformation, when the deforming force is removed, it doesn't return to its original shape. So that is plastic deformation. Elastic deformation, when the deforming force is removed, it returns to its original shape. If something is deformed plastically, when the deforming force is removed, it doesn't return to its original shape. Define and use stress, strain and the Young's modulus. Stress, we will learn about it in this chapter. Stress and pressure, we have the equation, similar equation. Pressure is force over area, stress is also F over A. But here the force is a compressive force or a tensile force divided by the cross-sectional area of the object. We will learn that. Then strain is extension over original length. We will learn that also. Young modulus is stress over strain. So we will see the details. Describe an experiment to measure the Young's modulus. Young modulus. Okay, so here you can see density equals mass over volume. This is that in symbols. Then pressure equals force over area. So this is the definition. Now here also we have the definition of density. Then here we have the definition of pressure. Now I have mentioned previously several times that you have to memorize these definitions. Whatever is in this green box, you have to memorize with understanding, because in the exam in paper 2 they can ask you to write these definitions. Okay, so this is basically the conversion factor. 1000 kilograms per cubic meter is equal to 1 gram per cubic centimeter. So very simple. If you want to convert from this unit to this unit, you can use this conversion factor. Density of water is approximately 1000 kilograms per cubic meter or 1 gram per cubic centimeter. Now based on this knowledge, you can answer these questions. Okay, so you will have to use this equation, you may have to use this conversion factor and answer these questions. Now the equation for volume of a sphere is 4 over 3 times pi r cube. You have to know this, and also you should know the equation for surface area of a sphere. That is A, the surface area, equals 4 pi r squared. Okay, then we have this equation, and you can see the unit of pressure is Pascal. It is what? Newton per square meter. Force is in newtons, area is in square meters. Okay, so you can answer these questions. Then we have the equation for pressure in a fluid. A fluid is something that can flow, like a liquid or a gas. All liquids and gases are fluids. There is an exception for now even sand, it can flow. So just for your information, sand is a solid, but also it is considered a fluid because it can flow. But generally always the liquids and gases are fluids because they can also flow. Then how do we get this equation? Now that is actually shown by this diagram and the explanation here. It's very simple. Now you can imagine there is a cuboid or a tank that is rectangular, a rectangular tank with water filled like this. Now the area of cross section here is A, and you know pressure is force over area. Volume of the water is area of cross section times the height. Volume of water is area of cross section times height. You can see it, because this you can consider like a prism. Then area of cross section times the height will give you the volume. Okay. Then mass of water is what? Based on the equation for density, mass is density times volume. So the mass of water is density of the water times the volume of water. And previously for this volume of water it's A times H. Okay. So mass of water is density times the volume. Volume of water is A times H. So we have rho AH, rho AH. Okay. Then you have learned the equation for weight. Weight equals mg. W equals mg. So we already found what the mass is. Mass is this rho AH. Rho AH. Okay, this one. Then that is the mass times G will give you the weight. Okay. So pressure equals force over area. Then force we know is the weight here. Now the force here is, alright, so we have this the force here, the force exerted here is the weight of the water. The weight of the water is what? This. So we already found that, right? Rho AHG. Rho AHG is the force. Then the area is A here. So we divide that by A. Now here also we have A, here also we have A. So the A here and the A here cancels. We get pressure equals rho GH. Now that's how you get this equation. Pressure equals rho GH. You should know this. Okay, pressure equals rho GH. You should know the derivation, and you also should know this equation. Okay, so based on what you have learned so far, you should be able to answer these questions. We'll go through another example. We'll go through an example actually where you will have to use this equation. Okay, so worked examples. Work 2 examples are there. A cube of side 0.2 meters floats in water with 0.15 meters below the surface of the water. The density of water is 1000 kilograms per cubic meter. Calculate the pressure of the water acting on the bottom surface of the cube and the force upwards on the cube caused by this pressure. This force is the upthrust on the cube. Okay, so this diagram is actually for the second example. Now this first example doesn't have a diagram. So we have a cube. A cube has all sides equal. So we know the length of one side, and it is 0.15 meters below the surface of the water. The density of water is 1000 kilograms per cubic meter. So we want to find the pressure of the water acting on the bottom surface of the cube and the force upwards on the cube caused by this pressure. So upthrust you have may have learned is the difference between the force at the top and the force at the bottom. I can even draw a diagram and show you. Now say for example you have an object. Now in this case the object is a cube and the cube is inside a liquid. So let's draw a diagram. So let's say this is the container. This container has water or some liquid. Okay, then the cube is inside this. Okay, so this is I'm going to draw the cube. Okay, this is the cube I'm going to draw. Now you can see that the top of the cube is below the surface of water but at a lesser height. So for example, if I consider the height from here to here, okay, so let's call that a certain height, and then from here all the way to the bottom here, that is a greater height or depth we can say. Okay, so here we have h1, here let's say it's h2, then there is a force here. Okay, due to the pressure we have a force there, and the force at the bottom here is greater. Okay, so I will use a different color. Okay, so we have a force here and also we have a force here. Now this force here F2 will be greater than the force here F1. Okay, because the pressure here is greater than the pressure here. I can even write the equation. Now you have learned pressure equals force over area. Okay, so if I make F the subject of the equation, then F equals P times A. Now in both cases A is the same. The area of cross section is the same in both cases. Okay, so if the pressure now since the depth is greater, the pressure is greater. So if the pressure is greater, the force at the bottom is greater than the force at the top. Okay, so the force at the bottom is greater than the force at the top. Now what is upthrust? We have learned that upthrust is equal to the weight of fluid displaced, that is Archimedes principle, and it is also equal to the difference in the force at the top and the bottom. So we can say the upthrust U is equal to F2. Now remember, F2 is greater, F2 minus F1. And remember, in the exam, if they ask you what is that cause of the upthrust, you have to say it is due to the pressure differences. We can also note that down. I will type it here. So we can say, remember, it's not due to the difference in the force. In the exam, if they ask you, the upthrust is due to the difference in the pressure. Upthrust is due to the difference in the pressure at the top and bottom surfaces. Okay, so I will type it here. Upthrust is due to the difference in the pressure at the top and the bottom surfaces of the object. Now in this case, the object is the cube. Okay, I think make it a little bit bigger. Okay, that's better. Okay, now let's go back to the example. This diagram can help you to understand the example better. Okay, so the cube is of side 0.2 meters, and okay, so there is a small problem with this question. Now what I explained is the correct thing. So the upthrust is due to the pressure differences, and it is also the upthrust is due to the F2 minus F1. Okay, now what the book has said is actually finding F2, and F2 is not the upthrust. Upthrust is due to the difference in these two, but the book vaguely says that it is the upthrust. Anyway, I will first explain this, and then I think you understand that upthrust is actually the difference in these two. Okay, so let's see what the book says. Now this here 0.15 is actually H2. Alright, so I edited that. Now from here to the bottom of the cube, that is 0.15 meters. From here to the top, if you want to find that, what you should do is H1 will be 0.15 minus 0. But this is a greater length, right? Okay, so what I said here, this is correct, because if it is from here to here, it can't be 0.15 because already this is 0.20. Otherwise the cube should be floating. Okay, yes, actually in this case I think the cube is floating. Okay, so don't confuse it. So what I said is a different example you can think. Okay, so what I said so far is correct, but in this example this is also correct, because in this case we can assume that the cube is floating. So I will draw a diagram for that also. Alright, so I have drawn this diagram. Now this is what the book is saying. Okay, so here this force F2 is the upthrust. Why? Because the force here is very small. It's due to the air. The force exerted this way due to the air is very small compared to the force here. So that's why, now remember again, upthrust is what? The force at the top minus the force at the bottom minus the force at the top, this one. But F2 is negligible, it's almost zero. So I wrote it like this. Therefore, the upthrust is equal to F2. And this is exactly what the textbook example is saying. So the cube has each side 0.2 meters. Then below, it is below the surface of water 0.15. So if we find the pressure here, okay, at this depth, that will be the pressure exerted here. Now if we know the area here, then we can find the force F2, and that is exactly what is done here. Okay, so what I said, okay, we can consider it like a different example, but what the textbook is saying is this. So now what is happening here? First we can find the pressure here. Okay, pressure here, that is rho g h is the depth, 0.15 meters. So rho is 1000, g is 9.81, h is 0.15. So we get this pressure. Now this is the pressure over here. So look at this diagram, just consider this as something different else, but what I explained here is also correct. Okay, so now let's go back. Now what we know is we can find the area, base area of this cube. Okay, so here also this is a cube exactly like this, but this cube is floating. So the base area here is 0.2 times 0.2, which is 0.04. Now pressure equals force over area, so force is pressure times area. Okay, then the pressure is 1470 we found here. Okay, the pressure here is what we found over here. Then the area here is 0.04, because it's a cube, it's one side squared will give you the area. And then we can use this equation, pressure times area is force, pressure is 1470, area is 0.04, then we get 58.8 newtons. Okay, so the force here is 58.8 newtons. Okay, so that is how you do that. Now let's go to the next example. Figure 7.3 shows a manometer. Manometer used to measure the pressure of a gas supply. Okay, so you can see over here. Actually, we'll first discuss this. Calculate the pressure difference between the gas inside the pipe and atmospheric pressure. So there is pressure here due to the gas, and here it's open to the atmosphere, so the pressure here everywhere, even at the surface of the liquid here, is the atmospheric pressure. Now the pressure here is the pressure of the gas, and it is the same pressure at the surface over here. So this pressure here is greater than the pressure here. Okay, the pressure here is greater than the pressure here. That's why this liquid level is down and this liquid level is up. Because if the pressure is here is greater than the pressure here, this will push the liquid down, and therefore the liquid level here is higher than the liquid level here. Okay, so now we can find the pressure over here at this level, and the pressure at this level is equal to the pressure at this level, because in a liquid the pressure at the same level is the same. So if you consider the same horizontal level of anywhere along inside the liquid, the same horizontal level, the pressure there will be the same. So this is important point, you have to know this. The pressure here and the pressure here at the same level anywhere in a liquid is the same pressure. If you consider even this level, so if I go along this horizontally at the same level, same height, the pressure here and even the pressure here are the same. Okay, so the pressure here and the pressure here are the same. That means the pressure here is what? The pressure due to this height of liquid, the pressure due to this liquid, and the atmospheric pressure. So we can write an equation. Let's do that right now. Okay, so I have drawn the manometer here. Now you can see the manometer on this side of the manometer is open to the atmosphere. So here it is the atmospheric pressure. Now here there is a trapped gas, and the pressure in the gas is greater than the atmospheric pressure. That's why the liquid level here is down, the liquid level here is up. This is what we call the manometer. The U-shaped tube is the manometer. Now I told you previously, pressure is the same in a liquid at the same horizontal level. That means the pressure here and the pressure here are the same, but here the pressure here is the pressure of the gas here. Okay, so the pressure of the gas here is the same as the pressure there. So therefore I can write an equation, the pressure here is equal to the pressure here, which is also equal to the pressure of the gas. So I write P gas, the pressure of the gas is equal to the atmospheric pressure plus the pressure due to this column of liquid. So that's what I wrote here. Okay, so the pressure here is equal to the pressure of this column of liquid plus the pressure due to the atmosphere, because all of that is pushing down here, and due to the weight of this there is pressure here also. So the pressure here, which is equal to the pressure there, which is equal to the pressure of the gas, is equal to the atmospheric pressure plus the pressure due to the column of this liquid. So the pressure due to the column of this liquid is rho GH. Now you can see this is the pressure difference between the pressure of the gas here and the atmospheric pressure. So if you make this the subject of the equation, you can see that that is equal to the pressure of the gas minus the pressure of the atmosphere. So this is the pressure difference, So we can basically say manometer measures the pressure difference. I will write that also. Okay, so I wrote it here, manometer measures the pressure difference. Now let's go through the example. These are very easy if you understand these main concepts. So like what I explained here, these are the main points that you should know. So once you know this, you will see that there are a lot of questions involving this and you will be able to do that. Okay, so let's do this now. Shows a manometer used to measure the pressure of a gas supply. Okay, now how do you find the pressure of the gas supply? Very simple, you can use this equation. And I told you how to get that equation. Calculate the pressure difference. See, pressure difference between the gas inside the pipe, that is this gas, and the atmospheric pressure. So what you are supposed to find is rho GH, right? Okay, so let's see. Determine the difference in the height h of the water on the two sides of the manometer. Here the height is 60, here the height is 30, right? So you can see here 0, so the 30. So the height difference is 30. So we want what? Rho GH, right? The pressure difference. So therefore we can use this. So the difference is what? 60 minus 30, which is 30. So now we can use it here directly. The liquid here is water, the density is 1000. Remember, pressure difference in a gas is rho GH, and that is the same rho GH here. Okay, so rho is that, G is 9.81, H is 0.30 meters. Now this is in centimeters, we can convert it to meters. So we get 2940 pascals. Okay, so that is the main, this note actually explains the main points you need to know in this kind of manometer question. And also I told you, manometer measures the pressure difference. Here they say the pressure of a gas. Yes, you can, now if you know this and if you know the atmospheric pressure, then you can also find the pressure of the gas. But manometer measures the pressure difference. Barometer measures the pressure. So remember those two. Alright, so we will end this part of the video here, and in the next video we will continue the rest of the lesson. For more information about our online classes, have a look at the video description. There you can buy the complete A-level physics course. That is the link to purchase that is in the video description. There are recorded theory lessons, there are solved tutorials, solved past exam papers, notes, PDFs, everything you need to get an A grade for the Cambridge AS and A-level physics exam is there in this complete physics course. It can also include some live sessions. So for more information, check that. And also, if you don't want to buy our complete online physics course, if you have like specific doubts, if you want an online class, for that also check the link in the check the information in the video description. There are thousands of students in our classes, online classes from different parts of the world, and you can see the testimonials on our website. For that also the links are in the video description. There are students who were C and D grade students that went on to become A and A star students in a very short time, maybe in like one month to 3 months, some even in one class. Okay, so for example, if you go through paper 5, paper 3, you can see once I explain the main points, then just even in just one class they can come to an A star grade. So all of that, the testimonials are there by the students. You can check that in the link is there in the video description, and also you can read the comments in this channel, what the students have said. There are so many students, just even by just watching the videos, they have done very well in their exam. So imagine now, just by watching, if you can gain so much, imagine how much more you can gain from an online class, from a real from a live class. Okay, so for more information, check the video description, and I hope to see you all in the next lesson.